So let's dive into the next part of the menu. And just so you know, I'm not sort of deliberately like hiding things from you here. There are obviously quite a few extra sub-menus here in the camera setup. We've got light metering modes, auto exposure modes, shockless white balance, things like this. These all pertain really to automatic modes, which I wouldn't ever use. So I don't need to worry about those. And this is the type of thing, this is what the manual's for. Okay, you don't need to watch me giving you, hopefully, nuggets of gold information for this kind of stuff. This is just, read the manual. It'll tell you everything you need to know. And if you're anything like me and you're shooting in a fully manual way, then these are meaningless anyway. The autofocus is dimmed at the moment because my camera's in manual focus mode, and there's a whole separate chapter about the autofocus, so we'll come back to that. Same with the face detection. Now in this menu, there is one particular thing which is relevant to what I'm just about to talk about with the pitch profiles, because that relates back to the base ISO, about dynamic range, your noise floor. There's a lot that kind of overlaps here. It's worth talking about the ABB, the auto black balance. Now, you should perform a black balance with this camera, certainly before every shoot, I would say, but even I would say just part of your maintenance routine prior to any shoot. Even if you're prepped, let's say you've prepped for a shoot on one day, packed all your gear into a car, driven off, stayed at a hotel, camera bags in the boot securely, and then you come to it the next day and go off on the shoot. The drop in temperature of just the camera being in the boot of your car overnight, for example, would be enough to throw off the black balance. So I would recommend attaching the body cap and performing an ABB if you are in any doubt about temperature fluctuations with the camera body and where it's been prior to you shooting. It's a very quick process. I won't do it now. And the key reason I won't do it now is because I don't have the body cap on. I have the lens with the lens cap on, but that is not good enough. You have to do an ABB with the body cap on and completely exclude light for it to be able to do that. And what it's doing is it's reading the sensor, and it's actually mapping out any kind of problems with the sensor. It's recalibrating the internal noise reduction. It's doing lots of good things which will optimize your image, particularly in terms of noise when you're shooting. So you should do it as part of your regular maintenance, or as I say, if there are big changes in temperature when you're going to shoot with the camera. So that's just on our way across to the next one. I'll just divert briefly onto that ABB. Digital image stabilization we're going to talk about in a separate chapter as well. So moving on, our next main page, the custom picture menu. As I said before, I am currently in the custom picture mode 5. You'll see if I go in there that it's got a little lock next to it. There's several there which have locks on them. Those are the presets that come with the camera that are by default locked, although you can unlock them and you can adjust them. But it's a good idea, I think, to just leave those locked, because there are, in fact, if I just move on, below here, you can see there's tons and tons of blank user entries that you can use. I find user 20 is particularly useful because you're not forced to go back up through the menu. You can just cycle down one and that will go back around. So actually, that's a very quick way to move between what's actually my most commonly used preset, which is the YDR mode, to something else. If there's something particularly exotic or unique that I wanted to set up, I can just move one to get there. But there are tons of blank user ones that you can use. Now, BT709 has kind of now earned itself this reputation as being the devil, the last possible mode that you'd ever want your camera to be in. I must stress, BT709 works actually very well for most scenarios. Out in the real world, it starts to fall down, of course, once you get to anything that's whiter than a white fluffy cloud or a white piece of paper. Essentially anything that's 90% reflectance or higher, and particularly obviously specular highlights, reflections, light sources themselves, the sun, whatever it might be. Obviously it all goes to hell there, and that's where you get these very nasty highlight roll off, this kind of dog leg at the top of the BT709 gamma curve, where you experience this very video-like and sort of nasty highlights. And of course that's not particularly pleasant, and given that our cameras don't have to suffer from that anymore, I can understand why you might not want to use it. But just bear in mind that you might well be delivering something to someone where there's, two things might be happening. simultaneously. You might be delivering to someone who isn't going to be able to colour grade it or doesn't want to colour grade it. It might be a live production, or it just might be going to somewhere where there's not the budget for a colorist, and you know that the person editing it isn't going to be able to grade it. But also, if your scene contains 10 stops of dynamic range or less, which is not unreasonable, the scene that you're looking at right now contains probably less than 10 stops of dynamic range, then there's actually no reason why you can't use that BT709 quite happily. I've certainly shot with it for certain things, and it's worked perfectly well. So understanding why something isn't good in certain circumstances is much more valuable than just hearing, oh, Rec 709 is bad, log is good. You need to sort of dive a little bit deeper to understand those things. So one of the main things that I like about BT709, even if it's just a transitory thing that I'm using it for, is that it lines up perfectly when you are pointing your camera at a chart and you're wanting to expose based on a known 90% reflectance value. So let me show you what I mean. I'm going to take my lens cap off and I'm pointing. Let's focus the camera. Not that it has to be in focus, but it's just a little bit more pleasant to look at, isn't it? I've got a riveting scene here. Absolutely riveting. A chart propped up against some stands. Really fascinating. I'm sorry it's not more interesting for you right now, but it serves the purpose, which is to demonstrate where BT709 I find can be quite useful, a bit of a hack, to be honest. So that top chip on the top of the chart there, you can see that white chip is exactly 90% reflectance. Now, if I look at my waveform monitor, which is in the middle right-hand side of the screen, the menu there, you can see that, in fact, if I move the camera, if I just move it left and right, you'll see it moving. You can see there's a kind of a flat-topped area, fairly flat-topped anyway, which is sitting just above, only slightly above, 90 IRE on my waveform monitor. Now, a waveform monitor, for those of you that aren't familiar with them, is essentially like a histogram, but where a histogram plots pixels from 0 to 256 left to right, a waveform flicks that round and will plot them from 0 to 256. Now, actually, that's a data scale that I'm saying. So normally for ease, these things are shown as an IRE, where you have 0 is black and 100 is white. Suffice to say, you're seeing dark things at the bottom and light things at the top with a waveform monitor, whereas on a histogram, you'd be seeing dark things on the left and you'd be seeing light things or bright things on the right. The benefit of turning it around and using a different axis is that then frees up your x-axis to actually plot your image left to right. So in other words, because the white 90% reflectance chip is in the middle of my frame, it appears in the middle of the waveform monitor. And as I move it now, it's on the right-hand side. You can see it's on the right-hand side of the waveform monitor. So essentially what that means is it makes it very easy for you to identify specific features within the frame and then find out how bright is that object, which of course you can't do at all with a histogram because it's essentially a bar graph. It's just averaging the whole frame, looking for pixels of a certain value and then stacking them up left to right. So waveform monitor is something that if you've not used to using it, I'd highly recommend it. In this case, I can see that that 90% chip, that 90% reflectance chip is sitting just above 90 IRE on my waveform monitor. Now, that works because I'm in BT709. And with BT709, it's 90% to 100%. That's where the really nasty dogleg comes in. So if you've got a scene and you're using a chart and that white chip is the brightest thing in the scene, you've essentially got a scene that's 10 stops or less, and you've got something that will fit very happily into BT709, and you don't need to worry about grading it, which might well be a huge benefit to you. It might be that you're very good at grading, or you expose very accurately and white balance very accurately, and the LUTs work perfectly for you, but it's just worth bearing in mind. Now in this case though, let's say I don't intend to shoot BT709, maybe my scene has more dynamic range, or will do once I open the window or whatever it might be. The fact remains that if I expose my subject where this chart is in BT709 and that 90% reflectance chart sits at 90, as I flick through my custom profiles, for example, if I go to log 3 now, just wait for it to reload, as I come out of there, you can see very clearly that part of the chart that refers to the 90% is dropped way down. It's dropped down to 60 IRE. my exposure hasn't changed, and this is a crucial concept when it comes to exposing log. I have changed my gamma, I have not changed my exposure. 90% reflectance charts should be exposed at roughly 60 IRE when you're shooting most log profiles. Each log profile, different cameras, slightly different. But here you can see it was at 90, which means it's correctly exposed. Now I've changed the gamma, it's now at 60. My exposure is still correct. I can prove that because if I go across to my monitoring setup into my view assist, I'm going to turn my view assist on the HDMI. That way you'll be able to see it in the recording. Come back out of the menu. You can see it looks correct. It looks like it did when I was in BT709, proving my point. This is still exposed exactly the same way. But if you look at the waveform monitor, you can see that the waveform monitor is still showing that 90% chip at 60 IRE. My reading, the waveform monitor is always reading off the sensor, and it's taking into account what's actually coming from the sensor with the custom picture in mind. So it's not going to be fooled. This is just a display LUT, a view assist, they call it in the camera, which I've applied to the HDMI output. So on my camera, I'm still seeing the log image, the log 3 image, but on the Ninja, I am seeing the view assisted mode. So it essentially looks the way that it did before. Now, that demonstrates exactly what I'm saying, that this is not going to adjust my exposure in any way. And therefore, it's a very simple way to expose log. You can do this on any camera. If you're not sure where exposed is for a given gamma curve, any log curve on any camera by any manufacturer, just stick it in BT709, find something that's a white piece of paper, it could be a white fluffy cloud, or if you've got a proper chart, a known 90% reflectance chip like we have here, expose that at 90 IRE in BT709, and then change your gamma to whatever log curve or hybrid gamma even, and it will still be correctly exposed. It doesn't change the exposure. It simply changes the way that the camera is interpreting those signals from black to white and maximizing the dynamic range. There's other things that it will change. So, for example, the R5C is also, when I'm in log 3, it's also actually changed the gamut as well. And I'll talk to you about gamuts and color matrices in a second. So that is an important point. Let's turn this off and let's come back over to my picture pro. So I'm in log 3 at the moment. I'm going to go to YDR, and I just want to talk to you about YDR for a second. Now, YDR is actually a really useful hybrid mode, if you like, because it's not a log mode. It's much closer, in fact, to BT709 mode. The key difference is that from about sort of middle grey, just above middle grey up, it gently rolls off the highlights in a way that you don't get with BT709. So what it's doing is it's actually giving us from middle grey down exactly the same as Rec 709. We're getting black to middle grey mapped the same way. So you won't actually see anything change between those different modes. So I just turn on my light that I've got here, as if by magic. There we go. Of course, this is the correct way to get exposure, not just ramp your ISO up until it's exposed and suffer all the consequences. Obviously, introducing light here. I'm just using a simple LED light here just to illuminate my subject, the chart in this case. If I go back into my BT standard, and I'm just going to adjust my aperture in this case, just to get this down. So my light's to one side, which is why the chip is at an angle, you can see there, but the right hand side is just, that's a little bit too much, that's a little bit not enough. This is where I could benefit from the fine increments look on my iris. Let's just have it about there, that's fair enough. So this is technically exposed because my subject, the key side of my subject, is sitting at 90 IRE. I'm in BT709. Now look what happens when I change that into YDR. Okay, can you see that white chip at the top there, it's dropped down, and whereas it was sitting just above 90, it's now sitting just below 80. In fact, what happens is a 90% reflectance chip that was exposed at exactly 90 IRE in BT709, in YDR it will drop down to 75 IRE. Now, that is because the middle grey and up, so the top half of my signal, has now got a very gentle roll off. So whereas with BT709 it kind of goes up quite nicely, it's quite a nice contrasty, realistic looking curve, but then it just falls across at the top and it has this nasty dogleg at the top at 90 IRE. With YDR, it solves that by maintaining the bottom half. So actually, you should notice, if I flick back again, you should notice that the bottom half of the waveform, in other words, the bottom half of my scene from middle grey, which is the second chip down, the one underneath the white one, everything below that isn't any different if I flick between these two. But everything above that has just come down slightly and it's just rolling off. And that gives you a far more pleasing highlight roll off and brings back some extra information, obviously a bit more dynamic range, but without it being a full log curve. And as such, you don't need to color grade it. It's particularly useful if you have strong light sources on skin, particularly Caucasian skin, which is more reflective. It does a good job of evening that out and creating a more gradual, a more pleasing roll off. You are still going to have things clipping. It's not some magic curve, but it is going to be particularly useful for run and gun situations where you're not sure what you're going to find. Really good if you're doing documentary work and you don't want to have to kind of color grade the whole thing yourself. It's just a really nice kind of adaptive, dynamic, responsive curve that sits halfway between BT709 and log 3. Knowing the numbers is another way that you can expose this correctly, of course. If I know that a 90% reflectance value falls at 75 IRE when I'm in YDR, then of course I can just leave it in YDR and just expose accordingly. So the trick I showed you there about using the BT709 standard mode and setting the 90% reflectance chip at 90 IRE, that's only if you don't want to have to learn what the different values are for different curves. And the nice thing about that is that works across all cameras ever. Whatever gamma curve options that camera has, BT709, 90 will be at 90, and then you change it afterwards. If you're only using Canon and you're only using these, or even particularly just the R5C, then you only need to learn two. YDR 90% reflectance drops to 75 IRE, and in log 3, if I select that, as I said before, that 90% reflectance, it drops to 60 or just under 60. If I know those values and I can commit those two numbers to memory, they're not hard to remember, 60, 75, 90, not too difficult to remember, then fine. But the nice thing about the BT709 trick is that, as I said, that will work on any camera. So if you're constantly using different cameras and are unsure where to map these different log values for the different gammas, or even if they're hybrid and they're not log at all, which is actually even more hard to predict, then that little trick can work really well. Plus, it illustrates to you that your exposure is not changing just because you're changing your gamma. What's changing is how the camera's mapping black to white, how it's distributing that luminosity, and therefore how it's handling the dynamic range of your scene, capturing more information into a smaller space that then can be brought back and graded how you see fit later on. So there's some important points there about the exposure and how exposure links in with these modes and the gamma of these modes. But I should point out, each of these presets is more than just a gamma, of course. It's a preset of several different things. So we can see here we've got BT709 YDR, that's the default. We have our Canon log 3. There's no log 2, incidentally, because the Canon have said that the camera supports about 14 stops of dynamic range. That fits very well with log 3. Log 2 brings in an extra stop or so of dynamic range, and most of that is brought in at the shadow, at the low end of the signal, which is perfect if you have a camera like the C300 Mark III, for example, or the C70, where you have a 16 plus stop dynamic range sensor. But in a camera with a 14 stop dynamic range sensor, it doesn't really make much sense to have a gamma curve that's bringing up extra information, because all it's doing is revealing more noise, and it's revealing parts of the image that you can't really use because they're too noisy, or not without applying a lot of additional noise reduction. So that's why log 2 isn't in there. Of course, you can, if you want, and you want to apply noise reduction and try and pull out as much additional dynamic range as you can shoot raw. And then, of course, that gamma is only represented as metadata anyway and can be changed in post-production. And then you can choose your log 2. You'll see exactly what I mean. All you'll get is a lot more noise in the shadows, but you can tease out then the maximum of amount of dynamic range from the sensor in combination with some noise reduction. So we have our YDR, we have our log3. There are presets for PQ and HLG, both HDR gammas, PQ being based on Dolby Vision, so this is a great way for producing HDR that you can then master to a specific nit value, a brightness. HLG being the dynamic HDR, which will adapt depending on the screen that's showing it, and therefore backward compatible with non-HDR screens. So those are the two reasons why you might choose those over each other. Again, if you shot RAW or even if you shot log3, there's no reason why you couldn't in post then grade for an HDR delivery. But what's nice about these presets is all the metadata is there and present, and if you want a simplified post workflow and you know that you're delivering it to HDR, then you can use those presets and go straight through nice and quickly. BT709 standard we've already seen. Now just below the BT709 standard there are two more additional presets. We have C6 EOS standard. Now that reproduces the image quality and look of a normal EOS DSLR camera, like a 5D Mark IV for example, and it has, quite importantly, a look file turned on, and that look file is assigned, essentially that's a LUT, that is assigned by Canon's engineers so that when you're in this mode you can partner the i5C with something like a 5D Mark IV. And C7 does exactly the same thing, but as you can see we have one called standard, one called neutral. They're both using look files. Now these are the match up with the image looks that are from those DSLRs. So the standard or the neutral kind of look, should not be confused with the color matrix, which shares the same name. Now if I look in here, you can see the color matrix is set to neutral, but that's not the thing that makes this neutral. It's the fact that the look file is set to conform to a custom picture, which is based on, hang on, if I go back up, you can see there it says look file EOS neutral.cube. So this is a 33 sized .cube LUT file, which Canon's engineers have made to mimic the neutral image profile of the DSLRs into a BT709 space. So this is why you have to be careful, because it is also using the neutral color matrix, which is something separate. But that word neutral kind of throws a spanner in the works. You can see what I mean, because if I go back up, so that's EOS neutral color matrix, but more importantly, and the reason why it's called neutral is because of the neutral look file. If I go to the EOS standard, I'm just going to edit, you'll see these are all grayed out because the protect mode is set to protect. These are the built-in standard ones. I can unprotect them and I can edit them if I want to, but I don't want to in this particular case. You can see the color matrix, it's also set to neutral. But if we look in the look file setup, you can see look file EOS standard. So it's mimicking the standard image profile of one of Canon's DSLRs. So a little bit confusing there because of the reuse of the word neutral there. But very specific reasons why you might be using C6 or C7. It would only be if you were partnering the R5C with one of Canon's DSLRs. So a very specific use case there. And then as we move through, there's all these blank ones, which of course I can go through. And just like I did with C20, I can edit it, I can customize it. I can then protect it if I want to make sure I don't adjust it. And I can make a lot of changes in there. Now what I'll do, just so it doesn't ruin my lighting in here, is I'm just going to turn my LED off. I'm going to put my lens cap back on because hopefully we've covered everything we need to cover in terms of the exposure side of things with these gammas. And what I'm going to do is I'm just going to show you some of the level of control that you have when it comes to customizing these custom pictures. So if we go into gamma and color space, if I go right to the top, I've got Canon Log 3 with Cinema Gamut. That's the default when you're in the Canon Log 3 picture profile, the C2 picture profile. When I'm customizing it like this, I can say, well, actually, I don't want the Cinema Gamut, which is a very large gamut. It's bigger than the human eye can see, in fact, in terms of gamut, which is done deliberately, obviously future-proofs the format in terms of what colors can be reproduced and then displayed. Any potential future display technologies can never exceed what our eye sees, or if they do, we're not going to see them anyway. So that's why Cinema Gamut exists. But what if I want to do Log 3 and pre-prep it for an HDR workflow by putting it into BT 2020, which is the gamut for Rec 2020 for HDR deliverables? Well, I can do that. I can customize this. that way if I want to. Or I might say, well, actually, I want log 3, but I want to use the standard BT709 gamut. So all of these custom pictures, they are a combination of gamut and gamut. And this is where, when we're customizing them, we can truly see that. But it's fairly hidden from you, or at least not obvious if you're new to this, when you're moving through the presets, that you're actually moving through a combination of things. So wide DR is using BT709 gamut, but the preset C2 is using Canon Log 3 Gamma, but then that shifts into the Canon Cinema Gamut as well. So if I don't want that, or if I want to customize it in any way, this is where I can do that. So all of those different presets there, if I back out of that menu, just using the cancel button on the back, color matrix. Now, we have the neutral color matrix, which is the default color matrix on all of Canon's cameras and has been for a number of years now. If you're in that default neutral color matrix, then it means that the way that the camera is plotting colors, obviously this is separate to where your white point is set. We'll talk about white balance momentarily, but assuming your white point is set accurately, then all of the colors that come from that white point, how they're plotted on that vector scope, is governed by the color matrix. And the neutral color matrix was designed by Canon to be completely consistent. So it's fairly faithful. It's one of the more sort of technically accurate. So when you shoot these charts and look at the chromaticity references for the primaries and secondaries on those charts, neutral color matrix does a great job of plotting those exactly where they should be. But what it also does is it does that very consistently from model to model. So if I'm shooting in a color matrix set to neutral on any of the Canon Cinema EOS cameras, or indeed their mirrorless cameras like the R5 and R6, and of course the R5C here, if they're all white balanced correctly, then they will match. They will reproduce colors and plot them on that vector scope identically between them. So it makes camera matching very, very easy with Canon. It's one of the main reasons why I choose Canon for all of our video productions, because of that flexibility. However, there are a couple here. You can see some additional options. So we have production camera. Now, according to the manual, the production camera color matrix reproduces colors more suitable for motion picture production. Now, what that really means is that Canon are actually giving us here a color matrix that's been tuned to fairly accurately reproduce the way that the Arri Alexa, the original Arri Alexa, captures and spreads the colors along its color matrix. You will not see that written down anywhere, but I have been told by Canon engineers that is exactly what that production camera color matrix is for. So if you ever find yourself mixing this camera into a production that has Arri Alexas on there, then in theory that will help with the matching of those cameras in terms of the way that they're capturing and reproducing colors. The video mode is a mode that will flick the color matrix into a more traditional video broadcast mode. So although the neutral color matrix captures and represents those chromaticity references for BT709 very accurately, they're not quite as saturated as they would be if it was a true video signal, old school kind of live production video signal. So if you were doing a multicam live stream shoot, then you would set it to video mode to give you those traditional test video patterns that you would expect for a TV broadcast. Very specific use cases for those, and as such, the neutral color matrix is the better one to choose. Beneath that, we have our look file. So when you're in certain modes, based on your gamma and color space combination, that will unlock this look file mode. And as I said before, that simply allows you to load in a LUT, a .cube LUT, which is burnt into the file. That's quite an important distinction there, because the look files are burnt in to the video signal, including going out to monitors and proxies as well. So if you're going to do that, that's fine, but you have to be very aware that that's a conscious decision that you're going for there. If I go to look file setup, this is where I can load in and register those cube files from an SD card. Don't have that with me now, but that's where you can do that. Now we've got additional options down here, and this gets increasingly down the rabbit hole and beyond the scope, I think, of this course. But we have control over things like our black pedestal. We have our level range and point mode adjustments for our black gamma. Essentially, what this is allowing me to do, it's allowing me to create my own tweaked gamma curve. Now, that's very specific workflow, but that is workflow that you might, particularly in combination with charts like these, choose to do if you were trying to match the gamma of the R5C to another camera. So if you have a chart with these various gradations from black to white, you can look at that on a waveform monitor live, using an external display like this, get it nice and big so you can see it, and you can then adjust the pedestal, the knee, all of these different things to actually move around, in this case, the lower end of the gamma, and really very accurately reproduce the way that the gamma of another camera is seeing the world. So this is sort of deep level camera matching stuff. Now, very useful thing here is we have quite a lot of control over the sharpness of the image. This obviously wouldn't apply to the raw mode because it's raw, it is what it is, and all of your sharpness would be done in post along with noise reduction and everything else. But if you wanted to, you could dial down or up the sharpness, but things like detail, frequency, coring level, these are giving me a huge amount of control over the sharpening of the image. And if you've ever done any kind of sharpening in DaVinci Resolve or anything like that, you'll be familiar with these level, detail, frequency, coring level, all of these different terminologies. But they are all essentially allowing you to control how detailed edge contrast and perceived sharpness of the image is. And it could be that you want to adjust this for a specific look that you're going for, or maybe a specific project that you're working on. Again, noise reduction, there's control over frame correlation, spatial, and you can set it from automatic to manual. So you can completely control the amount of noise reduction that's going on. So in theory, for example, if you wanted to use higher ISO modes where noise starts to kind of be introduced, let's say that you had something that you were shooting that was really low level light, you wanted to be at 12,000 ISO, you knew there was going to be a lot of noise, but you didn't have the workflow in place to be able to use noise reduction in post, which does have a really high overhead in terms of CPU load. It might be then that a workflow you could employ is to adjust the internal noise reduction and account for the fact that you're shooting at a higher ISO. Yes, the image is going to be slightly softer than it would be otherwise, but you can actually juggle this and get it so that all of that noise reduction is done at the point of acquisition, meaning that you can get away with that higher ISO level, but then also not have to worry about any kind of hit in post-production. So, these are all very specific workflows. Skin detail, amazing amount of control about the hue, the chroma, and the luminosity of skin, and you can tweak that depending on what you're trying to do. Color matrix tuning, so this will allow you to change the balance of your red, green, red, blue, green, red, green, blue, and such like. So you can see on a vector scope, you'll be able to adjust where the various different chromaticity references for the primary and secondaries are falling. So you'd obviously need to use a chart that contains those, and you could tweak them. So you'd be doing this most likely because you're trying to tweak the camera to mimic the way that the colors are reproduced in the color matrix of another camera. Maybe you need to shoot this with a Sony. You can adjust this camera so that it matches the way that the Sony sees the world using those color matrix tuning modes. Lots of different controls in here, and hopefully without diving too much further into that, you can see that what you've got in this custom picture menu is in fact a huge amount of control to kind of do whatever you want to do in terms of your image and how you're acquiring that image.